Welcome to the session of Introduction to Trigonometry, class 10. Here we will be studying some basic terms and how did it originate, trigonometry, what are its uses, and how we can find out distances, heights of some very tall objects or very far objects. So basically the word trigonometry has its origin from the Greek words trigonon, which means three angles, and metron, which means measure. So trigonometry signifies the measurement of triangles. Basically we'll be dealing with right triangles here only, and it deals with the study of the relations between the sides and angles in a triangle. Again we'll be dealing with right triangles, and as we know that triangle has six parts, three angles and three sides. Why it was developed? It was originally developed to solve the problems related to astronomy. It soon found applications to navigation and a wide range of other areas. It is used in architecture, it is used in engineering. You can see it is used to find distances between celestial objects. It is used to find out the height of the tall buildings, monuments, which is where it is not physically possible to measure, like the height of the mountain or height of a long tree. And therefore the origins of trigonometry lay in practical measuring the tasks of finding the unknown sides and the angles, and generally using the right angle triangle. As you can see that there is a right angle triangle formed. Similarly, suppose you are flying a kite and you want to know how high your kite is flying. Then we have to use trigonometry. Physically, it is not possible to measure when the object is very tall or far away. So a right triangle can be imagined to be made, a problem that can be represented with a right triangle and involves an unknown side, length or angle measure, can be solved using trigonometry. So we can see that there is a right triangle imagined to be made, and as we know that in a triangle there is a three sides and three angles. So if some are given to us, some unknowns we can find with the help of them. So trigonometry relies on the conservation of ratios between corresponding sides of the similar right angle triangle. Let us take an example. We will be using similar right triangles here. One example is Rahul would like to know the height of a certain building. He gets Aryan to hold up a 5-foot pole near the building and measures the length of its shadow. You can see the figure here. This is the building whose height we do not know. Let us denote it by h. The shadow it is making, it is 12 feet long, and meanwhile the Aryan also places the pole here, and the shadow of the pole is 3 feet. So this is the basic information that we have here. And what do we want to find out? We want to find out the height of the building. We can see that there are two right triangles. One triangle is formed by the building and its shadow, and the second triangle is formed by the pole and its shadow. As the light rays from the sun are parallel, the two angles at the tips of the shadows are equal. So the two triangles will be similar, as the two angles are equal. One is right angle and the other one is this angle at the tip of the shadow. So the third angle will be automatically equal. So these two triangles are similar, and we know that similar triangles have corresponding sides are proportional. So we can equate the ratio of the height and the bases in these two triangles. That is, h by 5 will be equal to 12 by 3, and by cross multiplying we'll be getting 3h equals to 60. So h by dividing by 3, 60 divided by 3 gives us 20. So in this way we can use similar triangles to find out the height or to make some indirect measurement. Moving on, because we will be dealing with the right triangle, let us once again revise here. A triangle with one angle is right angle is called a right triangle, and The side opposite to the right angle is called the hypotenuse. It is the longest side of the triangle, and the other two sides are called the legs of the triangle. Now, if the one angle is 90 degree, then by angle sum property, the remaining two angle sum will be 90 degree. That means angle B plus angle C will be 90 degree. So we can say that they are acute angles, or they will be less than 90 degree. So they are acute angle, and let us denote angle B by theta. So this is our symbol for the angle. And now let us name some terms. Name the sides relative to this angle. Now we can say that opposite side to this angle theta is AC here, and the side facing this. Adjacent side to the angle theta, that means the side which is attached to this angle theta other than the hypotenuse, is called the adjacent side. Here it is AB, and the longest side or side opposite to the right angle is BC. Now if we denote angle C by theta, then what will happen? Now this definition or the terms, the names of the opposite side and adjacent side will be changed. How? Because now the side facing the angle theta is AB now. So it is the opposite side, that is, it is AB. Adjacent side, that means the side which is attached to it other than the hypotenuse, it is AC. And longest side opposite the right angle is BC. These few basics we'll be using when we form the right triangles, and then we want to find out the unknowns also. Now let us take two similar right triangles, ABC and DEF. As we can see that angle B is 90, angle E is 90 here, angle C is theta, and angle F is theta. Now let us take some ratios with reference to theta. So we can see that AB is 3 units, BC is 4 units, AC is 5 units in this triangle, and DE is 6 units, EF is 8 units, and DF is 10 units in this triangle. So let us take some ratios. Ratios are in triangle ABC. In triangle ABC, we can see that opposite side to the angle theta, it is opposite side is AB, it is 3 units, hypotenuse is 5 units. So the ratio becomes 3 by 5. Similarly, in triangle DEF, we can see that opposite side to theta is 6 units, hypotenuse is 10 units. So by simplifying, the ratio again comes out to be 3 by 5. In the second type, we have the ratio of adjacent side to theta and hypotenuse is, adjacent side is 4 units and hypotenuse is 5 units. So the ratio is 4 by 5. And in triangle DEF, the ratio of adjacent side to hypotenuse is 8 by 10, or simplifying, we have again 4 by 5. Similarly, opposite side over adjacent side, it gives us the ratio 3 by 4 in this triangle ABC. And in triangle DEF, we have opposite side is, and to the adjacent side, it gives us the ratio 6 by 8, or simplifying 3 by 4. So we can see that because they are two similar right triangles, the ratio of these sides are same. So this is a unique property. Provided that one angle of right triangle is fixed, whatever is the size of the triangle, the ratio of the sides will be same. So this fact about right triangle leads us to trigonometric ratio. A trigonometric ratio is a ratio between two sides of a right triangle. In the coming section, you will study that this particular ratio, opposite side over hypotenuse, is denoted by a particular name. Similarly, adjacent side over hypotenuse is denoted by a particular name, and opposite side over adjacent side is also denoted by a particular name, which we will be calling as trigonometric ratio.